Well, hello and welcome everybody. Hey, this video, it's all about the vertex, especially from vertex form. Where does h comma k come from? How is that the vertex and what happened to the negative sign? This is the third lesson in our series on quadratic equations. It's actually the second offering in this third section. If you're a student and you're just learning this and you'd like some guided notes so you can record what it is you're learning, so you can think about it, reflect on it, remember it, and then use it as reference in the future, there's a link in the description. You can download those and get started. So go ahead and pause the video, grab those now. We're going to go ahead and dive into this exploration. Our goal is to have a geometric understanding of where that vertex formula comes from vertex form. If, though, you're just looking for some step-by-step how-to, you just need some practice with the procedure, got a video for you there too. So this would not be the video for you if you just need some practice. Go ahead and pause this video. I'll leave a link to the other one in the description below. But for now, let's go ahead and dive into this one. So vertex form, it's y equals a x minus h squared plus k. And the vertex is just h comma k. That seems so easy compared to standard form. It almost doesn't make sense. It's like a dirty trick. And the only thing that's really weird is why is that h positive? Here it's negative. Why is it positive there? Kind of a weird thing, right? Well, let's make some sense of it, right? Now, when you have a parabola, it's beautiful just like this, right? All quadratic equations, like a x minus h squared plus k, make parabolas, and parabolas are wonderfully symmetrical. That dotted line right down the middle, that is the line of symmetry, and the line of symmetry is equal distance. It's exactly in the middle of any horizontal pair like the ones you see here would be P and Q. Now, for this exploration, let's go ahead and pause our video right there. We're going to say that the endpoints, the horizontal pair, are x1 and x2. It's going to be a little cleaner for our exploration this time if we have those listed like that. So we're going to call that x1, that's x2. Now, since they're a horizontal pair, they're equal distance from that middle line, that line of symmetry, and we're going to call that point right there M. It's exactly in the middle. M stands for midpoint, and of course the formula for midpoint is x1 plus x2 divided by 2. All right, so set that aside for now. We're going to use that in just a minute, but let's explore our equation right here. So a x minus h squared plus k, well, let's say that this was equal to 0. It doesn't even really matter what number it is, but 0 is easy to do math with. Let's solve for x, okay? Now we're going to subtract k from both sides. Then we're going to divide both sides by a. Now to get rid of the parentheses, we have to take the square root. So we're going to take the square root of both sides. We're going to have to assume that either k is already negative or a is negative. Otherwise, we have an imaginary situation. Still wouldn't matter for this one, right? But the parentheses, there's nothing keeping them there anymore, so I can go ahead and add h to both sides, and the square root could be a plus or a minus. So over here at x1, we're going to have h minus square root of negative k over a, right? And the reason it's minus is because it's to the left, so we're subtracting. And x2, well, that would be h plus the square root of negative k over a. All right, so this is x1 right here. This over here, x2, is h plus square root of negative k over a. Now let's use our midpoint formula, right? M equals x1 plus x2 divided by 2. X1 is h minus square root of negative k over a, plus, right? So plus, and then x2, h plus square root of negative k over a, all of that divided by 2. Let's go ahead and rearrange this, put like terms next to each other. These over here, well, they're exactly the opposite. So when I add those together, they make 0. And then h plus h, well, that's 2h. 2 divided by 2 is 1. M equals h. Oh, that's kind of interesting. So right here, whatever that number is, it's the opposite sign. That is exactly the midpoint. The line of symmetry is x equal h. X equals h. That's pretty cool. All right, so we're going to go ahead and put that over there so we know what it is. Now, we need to find the coordinate, right, of the vertex. So x comma y, and of course y is a function of x. We write f of x. So we figure out this number and plug it in, right? Well, we know that that number for x is just h. So all we've got to do is plug in h to our function. So let's go ahead and do that. We have y equals a and then x minus h squared plus k. So we're going to get rid of the x, put an h there, And of course, h minus h is 0. 0 squared is 0. 0 times a is 0, so we're left with y equals k. So when x was equal to h, y is equal to k. That's pretty cool right there. That's why the vertex is h comma k. But did you catch it? Why is h positive in this formula when it's negative there? Well, the reason why is because we solved for x, and when we solved for x, we had to add h to both sides. Hey, I hope this video was, well, entertaining and enlightening. Hope you learned something, had a good time. If you did, give me a comment, a thumbs up, a like, a share, all that kind of stuff. Until next time, I hope you have a great day.